7.6, we're going to be solving exponential and logarithmic equations. And I'm going to divide them up into what I would say are three different sections, or types of equations. So the first kind of equation is, say I have something raised to a power, and it's equal to, and let's say there's a variable in here, it's equal to the same number raised to another power. If I have the same base on both sides, then we'll look at that kind of an equation. The next one is, say I have a log of some base of a number, and that's equal to the log of the same base of another number. There's, in these, in the x and the y stuff, there's variables involved. And the other is, I'll say, it's the form, or the kind of equation where you're going to be switching forms. And what I mean by forms is, and we've talked about this in previous sections, exponential and logarithmic form, right? So one type of equation that I might see would be a to the x equals b. I would take this kind of an equation and I would say log base a of b equals x. Okay, I would take this equation and switch it to here to solve for the exponent if there's a variable there. I might start out with an equation like this that has log base a of b equals x, and I want to solve for b. And then I would take this and put it in exponential form to solve for b. Okay, so this would be what I would call the third form, where you're switching between exponential and logarithmic form, or going the other way. Okay, so let's talk about that first kind, where a to the x is equal to a to the y. And I just want to talk about the concepts really quickly. We won't do many examples because those are for the sample problem videos. Well, if a is raised to the x and a is raised to the y, and these two things are equal to each other, then it only makes sense that x would be equal to y. Just for example, if 5 is raised to the second power, and it's equal to 5, and I'm going to raise 5 to some power, I mean, think about what power I would have to put here. Would anything else other than 2 make any sense? Could we put a 1? Would that make any sense? Or a 5? Or a negative 2? None of those things make sense. It would have to be a 2. So if this is an x here, and you're saying, what would I have to put there? Well, you would have to say that x is 2. Taking a little bit further, as 3 is to the third, and it's equal to 3 to the x minus 1, then we've got 3 and 3. The bases of the exponents are the same. So the only thing that makes sense is that these exponents would be the same, just like up here. If this is the third power, this would also have to be the third power. And if this is the third power, then the question is, what's x, right? If this is 3, then what's x? X is 4, right? So that's the basic idea there. How about this one's a little bit different looking, a little bit of a different, maybe more difficult to think about, right? This just falls right out of the sky. It's way easy, right? It just makes sense. This, it's a little more difficult to think about, but it shouldn't be. So what we're saying is there's a power they're going to raise b to get x, and then there's a power that we're going to raise b to get y. And we're saying that those powers are the same, right? I'm going to raise b to some power over here and get this thing, and I'm going to raise b to some power and get this thing, and those powers that I'm going to raise b to are the same thing, so the number that I get here must be the same. So let's use an example to think about this. Log base 2 of 4 equals log base. Now remember, never forget that this expression right here means what is the power? Find the power, find the exponent that I'm going to raise 2 to get 4, right? I need to find the exponent. Okay, so this means an exponent is the answer. So whatever the exponent is that I'm going to use to put to 2 to get 4, I'm going to do the same thing over here. It's equal. It's the same exponent, right? I'm going to use the same exponent for 2 to get this number. Well, if I'm going to use the same exponent as I use for 2 to get 4, then I must be using the same exponent over here, so I should get the same number, right? If I'm going to raise 2 to the second power would give me 4, then I need to get the exact same number here. Okay, like I said, that idea is a little harder to grasp in words, but it shouldn't take too much stretch of the imagination to see that this thing right here, since the bases are the same, this thing right here is the same as this thing right here, so 4 is the same as x. About log base 3 of 27 equals log base 3 of x plus 3, right? So if I'm going to raise 3 to some power to get 27, I'm also going to use that same exponent, equal, the same exponent for 3 to get x plus 3. Right? If I use that same exponent, then x plus 3 must be exactly the same as 27. So x is 24. I blanked there for a second. If all that is a little confusing, just break it down to this. If the bases are the same, if you've got the log of something equals the log of something, just simple as that, right? Nothing else, but the log of something equals the log of something. That's all that's involved. And the bases are the same, then just take these things right here and set them equal to each other, and then solve for x. No big deal, all right? We're going to talk about these types of equations right here. When you see it starts out with logs, if you start with logs in your equation, you need to check your solution, okay? And we'll talk about that in the future. So those are really all I wanted to talk about. I did mention the third kind, but that really just is a little bit of practice. I wanted to talk about the concepts of why can I set these exponents equal to each other? Why can I set these things equal to each other, x and y, 4 and x, 27 and x plus 3? Why can I set them equal to each other? And hopefully give you a little bit more of a depth of understanding rather than a how-to kind of a video. So we'll do some practice problems in the next videos. Thanks.